within machine learning, supervised, unsupervised, and reinforcement are kind of the original terminology for you classify a model. In what situation can you use a model? In supervised learning, your task of the algorithm that you use is to try to predict some value, some label. We'll be looking at examples. But basically, you feed a model with data where you have concrete examples of past data about what you're looking for. For example, if you have real estate prices for rentals and you feed a model with the characteristics of a real estate location, an apartment, along with its rental price, you can feed a model with a data set of that, and then you can try to predict the price of a new apartment that is going to be put on rental. The basic point here is that in the data that you feed the algorithm, there is a particular prediction variable that you're going to try to find. In this case would be the price of a new rental. And in unsupervised learning, it's different. You are not trying to predict a particular value. You're trying to discover a pattern within data that you don't have labels for. We'll look at it more in depth later. So I added this little table to differentiate between supervised and unsupervised, even though we haven't looked at it yet. But I thought it was useful to introduce unsupervised first. The key difference is here that supervised learning needs labels. You need something that, for example, in classification, like here, the label would be whether to approve or deny the loan. And in here, it could be the ice cream sales, or it could be a temperature that the weather station is trying to predict. But there's a particular label that you need to try to predict. And more importantly, in your historical data that you're going to feed into the model, you need the data points to have labels themselves so that the model can study the relationship between the explanatory variables like the candidate's credit score, their education level, those are explanatory variables, and the prediction variable, which would be whether to approve or deny the loan. You need that structure in order to use supervised learning models. Recapitulating, I don't know if that's a word actually, but regression and classification are the main tasks here for supervised. And here are some classical algorithms, which I'm not going to talk in depth about, but they are different manners in which you can use math in order to feed the data to different shapes of models. And whether to use one or another one, when you study how the math works, you pretty much gain an intuition about what situations they may be good or bad for. But in general, if you're looking at 5 different kinds of regression models, the one that you will use is the one that gives you the best performance. You need to try out different models with the same data set and iterate. That's why classical data science is not kind of a science and an art, because there's quite a bit of experimentation that is poking around with different models, changing the data in subtle ways to try to find the best performance. So when you work with a data scientist, be aware that data science projects have one issue, which is that you expect to get some level of performance, but you don't know what you're going to get until you feed the data to some model, and then you iterate on that until you eventually feel satisfied or decide that the data you have is not good enough to predict what you're trying to find. Well, and now to introduce unsupervised learning, it's for data where you don't have labels. Like if you had a set of loan applicants, you wouldn't have the decision variable. You wouldn't have a label telling you this was a good applicant or this was a bad applicant. You just have their credit score, you just have their their education levels. So in this scenario, you don't study a relationship between the explanatory variables and one outcome variable. You're just studying patterns in the data set by itself. So it's more pure in that sense. And typical tasks include clustering and anomaly detection.